Hello, everybody, and a huge thank you today for joining us for this discussion on building security into your engineering workflow. This is a lead dev webinar created in partnership with GitLab, and the webinar will last about 45 minutes, after which both myself and the panelists will head over to the lead dev Slack channel and will answer some of your questions in the process channel. We might also have time to answer some of the questions during the session. So if you post them into the Q&A on Zoom, we might be able to get a few of them in towards the end, but any leftover we will do on Slack afterwards. Let's get started with some introductions. My name is Luke Blaney, and today I'll be joined by Nimisha Asagari, Sharif Kuza, Yoseg Uza, and Cindy Blake, and we'll be sharing our experiences and insights about cybersecurity and engineering. So I'll ask each of you to introduce yourselves. Nimisha, over to you.
Thanks. Glad to be here. Thanks a lot, Luke, for the intro. So I'm Nimisha Asagiri. I had gotten my early start in my career focused on security, actually. And I had an opportunity early on to work with a startup that was implementing and designing peer-to-peer cryptographic protocols. And it was a must-have end-to-end security for all of our group messages, in transit and at rest. But now I am leading, I'm a chief architect and senior director of engineering at edX. So it's at a company where security is not necessarily top of mind. So now I'm leading architecture and engineering teams here. And so we're trying to now balance achieving user and product outcomes with, also being strategic about our security investments. So looking forward to having this conversation, very relevant to the industry and my work as well.
Cool, thanks. And Sharif, over to you.
Yeah, thanks, Luke. Thanks, Lead Dev, for inviting me. Sharif Kusa here out of Ottawa, Canada. I started my career as a software developer, wrote in a bunch of languages, Java, C, C++, ASPs, if you guys can remember that. That will tell you a little bit about my age. Active server pages. Wrote a lot of insecure software, got introduced to OWASP, and I kind of knew what I was doing. So I started learning more about security. I got my first job doing security code review for Wells Fargo. Did that for a few years and then started my own business, application security services firm called Software Secured, where we help small to medium-sized technology companies continuously ship secure code. And because one company is not enough, so we started another business to help software developers write secure code early on the software development lifecycle called Reshift Security. Glad to be here.
Thanks very much. And Yogesh, over to you.
Thank you, Luke, and Lead Dev for inviting me. Hi and welcome, everyone. Thank you for joining us. I'm Yogesh, a research engineer working for TRG Research and Development. My research areas focus on building and engineering solutions for crime and terror. I also build and maintain an open source project called Reengine. It's an automated reconnaissance framework meant for penetration testing on your web applications. And prior to working as a research engineer, I worked as a penetration tester for a couple of years on IoT and automotive. So I'm a hacker and pen tester turned into a research engineer. So I have a background on building and breaking technologies both, and I'm really excited to be here. I look forward to putting my views on where security should be a part of your engineering workflow, especially now with the Sift-led trend. I'll put forward my views from a hacker and from a developer's perspective. And I look forward to your questions. Thank you very much.
Great, thanks. And last but not least, Cindy.
Hi, Cindy Blake with GitLab, coming from Texas. I've been with GitLab for more than 3 years, really since the beginning of GitLab's security capabilities. And as one end-to-end DevOps platform, we've embedded application security into the process to really simplify DevSecOps. And full disclosure, previously I spent about 5 years at Fortify. So I understand traditional AppSec, and I'm really passionate about the need to do things differently and to marry the security and the development process together. I work with our customers on how to apply GitLab security capabilities within their DevOps environment. I see a lot of best practices and really excited to be part of this panel.
Great, thanks very much. That's today's panel. So security, I think, is something that if you read any news or anything recently, you'll understand it's a more and more important thing. Everybody understands the need to take it seriously. But I think the place we often struggle with is getting that balance. You can't spend the whole time in security. People have things they're trying to deliver. They're trying to build software. They're trying to give value to their customers. And trying to get that balance right, trying to really understand how much security is a reasonable amount. Where do you get that balance right? And I think that's something that many engineers and engineering managers often find it hard to get that exact balance right. It always feels like you're not quite doing enough security, but at the same time, you've got product managers, various people being like, do this thing, build this feature, get this stuff shipped out the door. I think, yeah, that's what we're going to be talking about today. And I think the first thing I'd quite like to hear a bit more about is this concept of shift left. You mentioned a bit of it in your introduction, and I know a lot of people have been talking about, we need to shift left, we need to shift left. But I was wondering, could you give just to begin with, what does shift left actually mean? Like, for someone who's brand new, has heard the buzzword, but what does it mean in practice? And you're saying, do you want to maybe take that one to begin with?
Yeah, sure. So recently there has been a lot of changes that has happened in the AppSec, right? A lot of sophisticated attacks have emerged, and the rate at which these attacks are happening is greater than ever before, and has become super difficult and expensive for security and SOC teams to keep up with. Because once your application and business has an incident, it is no longer just a software problem. It's a legal burden, it's a compliance issues, and probably a hefty fine. And you as of course, business and a developer, you don't want that to happen. So right now, it's very a good time that developers shift toward what is called shift left. And if you're a developer hearing us right now, you absolutely do not have to get scared of this term. This is just a fancy way of saying, hey, let's just move your security practices into the SDLC before the production. And also some may choose to say DevSecOps, right? You may have heard DevOps in the past. This one is including security in your DevOps culture. And this shift left is required because you want to move from a reactive to a proactive security posture. And this is not about just taking up some checkpoints. This is moving your entire security practices left. You move your security sprints, you move your compliance sprints long before it goes into production. As in when you write code, as in when you commit them, you're going to check against your security practice. And that's how you're going to make sure that you have achieved all of them, your proactive security, I would say, in proper. And this has a lot of benefits. The first and the zeroth one is probably going to make sure both developers and security teams are not amazed to see each other, because they both go in hand, and you're going to make sure that the security team knows what code the developer is writing and the dev team knows what are the security requirements. So they both go in hand. And this greatly helps in reducing your attack surface, because you as a developer, you are continuously adding the features, right? Because when you are adding the features, knowing the attack surface at the later stage are not going to help you. And this shift left is also helping in giving the cybersecurity ownership to every team, because cybersecurity is not just a SOC team problem or a centralized security team's problem. This problem needs to be equally distributed among the dev teams, your operation teams, and of course the security teams. And there are a few ways to achieve this. The first one is, of course, you can do to shift left is by implementing the best practices, security best practices into the requirement, into your design and coding phase of SDLC before even your dev team starts writing code. You need to think, I think you should think of security as a part of your requirement gathering phase. And the next step is to probably conduct a secure code reviews frequently when the application is still small and the code base is manageable. Because as your application is overloaded with features, it becomes expensive and time consuming to perform the code reviews. So perform the code reviews in small chunks and start when the application is still small. That is what is called a shift left.
Cool, thanks. And Cindy, do you have anything to add on this?
Yeah, I think the simple version is that shift left empowers the developers to fix the things that they're going to have to fix eventually anyway, but while they're working on the code in the moment. So it's much more efficient. You're not getting bombarded with things 2 weeks after you've moved on to the next project, right? It's while you're still iterating on the code, you get that insight to see what you need to fix. It's it's infinitely more efficient, and developers really, that do this really love that process and that method. In fact, usually with GitLab, what we see is the developers will bring in GitLab for security and then need to convince the security team to come on board as well. But it can really simplify your processes.
Cool. And I guess one thing that follows on from that is then what are the sort of what sort of challenges do we face whenever people start trying to do this shift left process? Sharif, maybe do you have anything to say on that?
Yeah, to me, some of the shift left, I just have to touch point on a little bit on what does shift left mean, and then I'm going to jump back to this question. Shift left to me, it's kind of like a mentality change in shifting all of the security checks that we'd have done historically in the past after production, shifted left in the software development lifecycle. Some of the challenges come from not getting clear on that mind shift between developers and security teams. So the challenges come in the sort of a friction between the security team and the developers because the expectations were not set. Comes from the fact that shift left means that we got to do additional activities in the software development lifecycle. We might have to change our CI. We might have to get extra work because now we're getting the security bugs before production, not after. When those expectations are not managed between the stakeholders in the organization, the product team, the development team, the security team, this is where you get the most challenges. Once you solve those problems, from my experience, the rest is easier to challenge. As which tools do we use? What exactly do we need to do? What kind of security activities? To me, is just a conversation and less of a problem to handle by the stakeholders.
I think part of that conversation is understanding what's the risk appetite that we have, and setting those policies. So it's one thing to automate the testing, but you need to automate the policies as well. So deciding what they should be up front is part of that conversation.
Absolutely.
I would like to add a couple of points here. I think some of the challenges that we have seen in the past, probably the first and foremost is the failure to collaborate with the InfoSec teams. Because what happens is it's an undeniable fact that the InfoSec teams know a lot about the depth and breadth of any attack, right? Security attacks. And so most often developers, they fail to collaborate with the InfoSec team because they simply do not understand the risk. And this could be easily fixed by educating the development team with the very common risk that the applications may face, something like probably a OWASP top 10. And this is a very important documentation that every dev teams and security teams must follow. And the second one that I have observed personally is, I think as we have something like class of clan, we also have class of tools, class of departments, and class of thoughts, and syncing them all together, right? Now, since your multiple teams are working together, you definitely have a class of tools, class of expertise, and class of different metrics. And it's very difficult to settle down at a mutual agreement when you where your team decides what tool to use, what metrics not to use, because it's an overkill, right? So there is no one tool that we can suggest you that fits the need of all the organization. It's probably the best found out when you sit down with your team, your operation teams, your dev teams, your security teams, and overcome the challenges of choosing that one tool that fits well enough, and then use it to build, deploy, and test it in a continuous manner. And the last one that I've seen is, your dev teams in failure to understanding the threat modeling and, attack surface mapping. Because what happens is most often the dev teams fail to understand the attack surfaces. And this is most often the crucial part, because when dev teams do not figure out the attack surface, it's quite impossible to do the security requirements gathering. And as the features in the application grows, I would say not necessarily, but most often the attack surface grows as there are a lot of components involved. So it is important that developer teams do understand the attack surface and eventually get a threat modeling. And do this when your application is still small. If you're not aware of what exactly is attack surface, it's an entry and exit point for your hacker. It could be your open ports, login page, data entry, CRUD forms, and the interfaces with the other application. So you might want to do this when your application is relatively very small. Because the smaller your attack surface is, the less likely that you have to get hacked, right? So the developers should work on reducing the attack surface and probably educate the developers on the risk and mitigations and work collaboratively with the InfoSec teams. I think this is going to fix the hurdles with most of the teams.
Cool, thanks. And perhaps I can bring Nimisha in here. Whenever we're talking a lot about moving more stuff, getting engineers involved earlier, a lot of this stuff about thinking about the threat modeling stuff. As someone who leads a lot of sort of engineering teams and stuff, how do you then balance that with them trying to, actually deliver stuff and getting to deadlines on time? And it sounds here like we're giving them a lot more extra work that they didn't have to do before. So how do you deal with those sort of conversations?
Yeah, I really like the conversation thus far on shifting left. I'd say that shifting even more left, like there is a function we haven't talked about, which is like the product organization, and getting the business counterparts part of the conversation. If that is there and we have together collaboratively decided what are the security risks that are high priority for the organization and the business, because each vertical is different, whether you're in the financial sector or health sector, or in my case, the education sector. For us, it's learner privacy is like paramount, in addition to just, baseline security issues. And so identifying, who are your user personas, what are your trust domains, and agreeing on what are those parts of our code base and environment that perhaps, let's say your e-commerce part needs to have PCI compliance. And so the amount of investment around security there might be higher than, let's say, another part of your platform. So the defense in depth there might be higher. And things like that. So really having that strategic perspective with our business counterparts helps the teams themselves move faster and being able to advocate for the security needs for the work that they are doing. And then we could talk a little bit more about, just the static analysis tools and the dynamic analysis tools and the different tools as well that can be just embedded in, in the giving tight feedback loops to our developers. And it's part of therefore their development environment as well as the CI/CD pipeline. And for us at X, like we have an XSS linter that we've embedded. We've also created a tool to detect CSRF issues by finding basically being able to intercept all GET calls to our endpoints and then being able to determine, and this is in your unit tests, we're able to catch in that call, do we make any write edits to our database? Do we spin up a new asynchronous task? Those things therefore are probably good indicators of a violation and a CSRF breach. So, and we could talk more about that as well.
Cool, thanks. Sounds like there's a lot of really useful tools there. Cindy, what do you think on this sort of, like, even with all those different tools, does having so many tools like slow us down by having to learn all these tools and that stuff? Or how do you see the balance between speed and security there?
Yeah, I think if you think out of the box and look at security end to end, it can actually be much more efficient. We had our user conference here a couple of weeks ago, and one of the Forrester analysts talked about how the CISO's chief challenge right now is complexity. And a lot of it has to do with all the tool chains, stitching them together, maintaining them, something changes, that breaks everything, keeping them current. It's really a nightmare. So having a single platform can not only simplify things, but get everybody on the same page with a single source of truth. So you're not taking what's found from security and then giving it to dev and trying to translate those findings into, where is this in the code and so forth. And also having the transparency and collaboration ability, becomes really, really important. So we've got one of our customers, HackerOne, was actually able to improve their velocity by 5x by using this approach. And it's more than a tool. It's really about, people, processes, and tools have to work together. And it's really about using the platform approach as an enabler of a more unified process.
Cool, thanks. And Sharif, where do you find that balance between speed and security then? From your perspective?
That's a very good question. I talk a lot to CTOs, and talking to CTOs will give you a very good understanding, because CTOs are kind of like chief problem solvers, right? And I see them solving problems in very, very unique ways. I don't like to start with tools, because tools are just tools, right? So we have to start by what are the requirements, right? And where do we want to be? What is the success criteria? And then tools is, how do we get there? And at Software Secure, we like to describe the best framework to secure applications is what we call the CASM framework, which is continuity, automation, scheduling, measurability. Continuity, a repeatable process, so something that has to occur over and over again, because we cannot check one release but not the next release. Automation, it has to be an automated process. If the developer has to click a button, then that's a problem, because the developer will forget to click the button. Scheduling, we have to understand when is this running and when it is not running, because that's where you get a lot of noise from the tools. If it's running on everything that is irrelevant, some of those events might be irrelevant. And finally, measurability. How do we know? Cindy just mentioned that CISOs, the biggest problem is complexity. And where this came from is 15 years ago, we had SaaS tools. So, hey, let's get the best SaaS tool in there. Then we had DAS tool. Let's get the best DAS tool in there. And then we had IST. Let's get the best IST, and then RASP, and then WAFs. And then, oh, this tool is better than this tool, so let's get two of each. That's where the enterprise ended. So you have a whole lot, but a whole lot of tools that they have to manage. Mm-hmm. Now, which tool is giving them the most ROI on their investment? That's a very rare metrics that you would see in the industry today. Maybe none of these tools are giving you anything. Maybe it's your pen tester, and maybe one of the tools are particularly giving you more ROI than the others, right? So just to answer your question, Lou, quickly, understanding the requirements, understanding where you want to be, put enough tools to get you there, start measuring and tweak. So this way you don't get overloaded with tools, which will slow you down, or processes or activities that would slow you down, and put enough tools or processes or activities that giving you the highest ROI on your investment throughout your security journey.
Well, thanks. So moving on, I think we've talked a lot about, especially when we're talking there with shift left and various things, which we sort of mentioned, having a security team and the dev teams, and, moving responsibility between the two. But one thing I've sort of been curious about in our own organization, we've been having various discussions, is around how do you actually structure those teams? I know there's a lot of different options for, do you embed people? Do you have a completely separate function? And I'm just wondering, where do people see that sort of, what's the balance these days? How do you sort of structure your teams to get the most secure thing? Nimisha, do you have anything on that?
Yeah, thanks. So we are asking a lot of our developers. Our definition of done is just continuing to increase, right? There's accessibility, internationalization, localization, there's one thing after another. Good design, practices, so we can sustain the platform, and now security as well. So there's a lot that we're asking of them. And so therefore there is, for some really small companies of team of size 5, company startup, you may not need this, but for larger size organizations, having a center of expertise on security does add value, so that team is able to provide guidance to others who are trying to also, deliver quickly and attain, achieve the business objectives and so forth. One way that I like to think about it is to think about, to actually leverage the DevOps team topologies model. I can put a link in chat as well. And the team topologies model from DevOps, DevOps and SRE, they themselves have been thinking a lot about this, and now with DevSecOps as well. So, and one of the things that they talk about is what is that inter-team API between the central team and the individual autonomous teams who are trying to move as quickly as possible. And they talk about these different modes of interaction. You have a collaboration mode, you have a platform as a service mode, and then facilitation mode. I think clarifying which part of the operating model in the software development lifecycle and at what points you want to have these team interactions could go a really long way. So for instance, collaboration mode. Maybe it's the initial design phase when you're building something completely new and you need to consult on product security requirements, and then you need guidance from this central team on what is the business's security, privacy, compliance standpoint. Maybe if you're assessing a new technology, collaboration mode could come into hand. And then facilitation mode, like maybe just training and education. I know Yogesh talked about education as well, and things like that. And how does actually one embed, some of the tools and other things that you provide into your team's dynamics and operations? That type of mode could be available. And then lastly, platform as a service mode, right? That's where the central team can, make the judicious decisions on what are those cross-cutting security tools and practices that we do want to put forth in the company, whether it's the SaaS tools or the DAS tools, all these things that we talked about, pen testing frameworks and so forth. So, and that becomes then a team that standardizes this for the company in terms of adoption. And then each individual team can decide which of these modes, which of these tools that they also adopt. And then this clarification helps the organization get clarity on when to use a central team versus not, without the central team being a blocker as much as possible. Because like Accelerate book, right, talks about change advisory boards as an anti-pattern in organizations, and we don't want security to be that. We want security to be an enabler for the business, not a blocker.
I think part of the key to doing that is having those views kind of across projects so that you're not having to have that conversation for every new project that gets spun up. So looking at it more holistically of, yes, what are the guardrails that we want to put in place, and then allow automation to enable those guardrails so you don't have to think about it with every single project.
Exactly. And that platform and service, like a lot of those things, if they can be automated, the better. You only need to talk to the security team if something's not working, or if you need and hopefully a lot of those things are documented with proper APIs that are asynchronously usable. Yes, good point.
Cool. And do you think that does that sort of shift some of the responsibility around security as well? Like if you've got this model where some people are opting into central things and other teams maybe don't opt to use certain tools, how do you have that sort of conversation around, at the end of the day, what happens if it all goes wrong?
Yeah, accountability is very important. We haven't talked about much of that too, but and I think we did talk about using a strategic perspective on this. And so the risk assessment for this, the KPIs, security related KPIs that are at the executive level and at the business level will then enable some of these accountabilities. But like I said, each team, because for large organizations, certain teams might be working on, let's say, internal tools versus, like I said, the e-commerce site versus, so their requirements will be different. Yeah.
Cool, thanks. So I think so far we've talked a lot about, how do we do stuff early on in dev and try and doing as much talking and stuff up front. But I guess security doesn't end once you push stuff to production, right? Just because it's there, like we still need to be constantly vigilant and that sort of stuff. Yogesh, what do you think dev teams should do from around security once something is in prod? What do they need to keep doing after that point?
I must say, I think this is the most exciting thing for developers, right? Because once the application is in production and I think, oh, I'm done. And now let the operation teams, the security team handle that, right? But that's not really the case. In Sift left, our DevSecOps culture, we need to maintain the feedback loop. Your developers, your security, and your ops team must be in the same. So dev teams, I'm sorry, we are not going to let you rest here. So as we move into everything continuous, I also think you need to follow up with the continuous security, both in terms of continuous integration and delivery as well, and maintain a very tight feedback loop. One of the things to go for is probably a DAST. That's a dynamic application analysis security testing, right? So this discovers the vulnerability in runtime, because now in the past, you must have done SAST, which discovered the vulnerabilities long before it was into compilation, right? right? So now since it's already in the runtime, you want to find out the vulnerabilities running there. So for example, from your source code, your SAST scanner may not have discovered the SQL injection. Now that the application is up and running, your DAST scanners might find SQL injections on runtime. And that is the difference between using SAST on pre-production and DAST after production, and why both of them are needed as they bring unique values to the table. And even after production, the dev teams must maintain a full, life cycle of the security platform and maintain a continuous penetration testing cycle as well. Because while you're moving faster to the left strategy, you also need to make sure the code, I would say, commits that you have done are secure. You need to follow the standards like OWASP top 10 very closely. And when teams are not aware of your standards and threats, they're most likely to encounter and the things that they may have never heard of. Suppose, I know at times it's very, as a penetration tester, it's quite simple to bypass the security loopholes. So developers need to be also trained with not just how SQL injection works, but also to how defend against the SQL injections. What are the different types of bypasses for SQL injections? And I think this is very important. And of course, there are a couple of other housekeeping things you can do. That's, as I said earlier, reducing the attack surface of your dev environment, because now the application has already gone into production. Probably you might want to move your dev environment and check if your a couple of housekeeping things, like check if your default credentials are working in productions or not, check if your dev teams might have pushed some API keys, credentials, and secret keys or not. Probably you might also want to run some sort of container scans. You might also want to do some sort of compliance scans and some license checks as well, because no any software is complete without using any open source components, right? So you also want to make sure that the components that you're pushing, you agree to the licenses. And a couple of other housekeeping, probably make sure that you are not operating your production environment from your dev environment, and keep a guardrail, or I would say, keep a very good isolation between your dev environment and production. I think that's pretty much from me. Probably, Serif, if you can get into deeper insight about this, I think it's.
Yeah, for sure. So I like to think about that as a whole process. When we were doing waterfall, it was easier, because you know what, we were going to a phase of security. I was just going to do everything that we can, and then we're done. Right now, we cannot do that anymore. So how do we do it? And the best way I like to describe it is the way the Phoenix project, if you guys read the book, how it described DevOps. So the 3 ways of DevOps work always like push code from as fast as possible from devs to ops, which is kind of like what most people understand as far as DevOps. And if you map that to security, it's basically what tools can I run into the CI that would give me the fastest checks. Right. The second way of DevOps per the Phoenix project is amplify feedback loops, which Yogesh just answered. And the way we do that is just by having good logging and monitoring, so that we understand if something happened in production, we understand the developer will be proactive about understanding what happened. They don't hear it from a customer, or worse, from a hacker. Right. And finally, continue with experimentation. And I had one client that was Alexa 1000. So they had a huge amount of traffic. They were very happy with this traffic, only to discover that 40% of this traffic came from bots. And right. And the only way they knew that is they ran an analysis on the traffic to understand where it was coming from. And 40% came from known bots that were doing nefarious stuff. So this is a team that went where they didn't really have to. They were happy with the traffic. There was no compliance to ask them to do so. They're a B2C in the first place, so they don't have a lot of regulations going on, but they were very proactive about understanding where they are. So this is kind of like the continued experimentation. So the same things that happen that you would do to improve your DevOps processes, they would apply as well to their DevSec ops processes as well.
Cool, thanks. And then I think following on from that, once we're sort of monitoring these things in production stuff, I guess for me, almost the next bit is, what happens when it all goes wrong? And, things do go wrong. And I think personally, as an engineer, when I worked in lots of other teams, and I think I'd been very involved with sort of operational incidents and that sort of stuff, I sort of knew how to behave quite well with those. But it was only when I moved to cybersecurity that I realized that security incidents tend to not be as widely publicized for quite good reasons, even within the business. So engineers don't, unless you're actively involved in it, you don't always understand what's involved in that. So I was wondering, what do people think are the main sort of differences, and how would you approach a security incident differently than maybe another operational incident? I don't know, Sharif, if you have more on that, or if anybody else wants to jump in.
Unfortunately, this is one of the underestimated disciplines, if you will, in security, while it's the most important. So go back with your memory and try to remember kind of like the most impactful attacks. So I don't know, Equifax, Sony PlayStation. And there is almost a direct relation between the impact of the attack and how well the company was prepared for incident response. How well did they respond to that incident? And you will find that the ones, there's a lot of attacks that went on that was even in the same magnitude or worse, but the difference is those companies responded very well to the attack. They were prepared, right? And the problem comes with, as in, well, the companies or teams, development teams don't have a process for how would they respond to an incident. They always push that back as, well, this is only for the big guys. This is only for the big companies. There will be a team to handle that. Guess what? Right now, everybody has to deal with this problem. And it's much simpler than people think. It's basically what happened. They have to answer 3 questions. What happened, right? Who was impacted? What do we need to do? The quicker that you can answer those 3 questions, the better your position will be in handling the incident. The quality of how you answer those questions will determine how would you recover from that incident, because every single company will have an incident. It's not a question about if, it's a question about when. So the quality of that process, it doesn't need to be complicated. Just answering those 3 questions: what happened, who was affected, and what do we need to do, right? So that's basically.
I'll also add that as consumers, right? Like, we have a position here. I mean, it's definitely an indication of the company, how transparent they are, right? Are they disclosing when these security breaches happen, whether it's your privacy of your data that was impacted or other things? And so I think as an industry and as consumers of the industry as well, whether you're a consumer of a open source project or of a third-party software, or even just direct B2C type customer, yeah, I mean, I think we have to hold our businesses accountable of being transparent and responding to these types of security incidents, because no one's going to be 100% perfect. And so actually, shifting left, and also on like these incident management design processes, communication channels, and all of that needs to happen. And yeah, Luke, it was a great point about production incidents and security incidents being very different animals, and there's a communication level to it and how we follow up. And yeah, I mean, for us too here, we disclose the incident to people who are interested in knowing about the security incident prior to us, especially because we have an open source project and we need to let our open source consumers and providers know about this so they can also update their sites in time. And so that takes a very different level of communication strategy.
And I think there's another level of interest in it growing in the US as well with the executive order on cybersecurity. I think we'll all have a lot more eyes on what's happening, and the ability to respond quickly is really dependent upon your visibility. Can you see who changed what, where, when across the entire software development lifecycle? And that, I think, becomes super important, as well as hygiene. When you look at the vast majority of the most impactful attacks have all come down to lack of hygiene. SolarWinds with passwords, using a simple password that wasn't changed, those kinds of things. If you can automate as much of that as possible and look for, secrets with every code change, and it can really alleviate some of the burden of that basic hygiene.
Yeah.
And I also think once you have recovered from the attack, the last thing the team probably might want to do is the housekeeping of lesson learning, right? You also need to figure out what changes needs to be made in the security that it doesn't happen in the future. You had to implement the WAF, you had to implement some sort of custom security policies. You need to learn those lessons. And you also need to find out where your employees are problem, or where the developers are the one who created the problem. You need to train them, how you can train them differently so that it doesn't happen in the future. And from a security perspective, you also need to figure out what weakness was that one particular, the breach caused, the breach happened. And you need to figure out that particular weakness doesn't happen in your entire organization, not just with one application. And also you need to ensure that the similar breach doesn't happen in the future. And how are you going to make sure that it doesn't happen in the future? So probably with your incident response team, with the stakeholders, with the team and the developers, you need to hold in after action meetings so that these things doesn't happen in the future.
Great, thanks. So we've got 5 minutes left. So I want to there's one topic I do want to touch on before we go, which is sort of it's around metrics and how do we measure some of this. And I know like in technology in general, metrics is always a really hard one. It's like how do we pick the right thing and not encourage the wrong behaviors. Personally, I find it even harder whenever you're talking around risks and it's uncertainty. Like nothing in security is like, oh, if I do this, this is going to happen. It's all about a risk and it's about that might happen and all that sort of stuff. So I was wondering what people think are like good security metrics to focus on, maybe across the organization, and what things maybe have you tried and you recommend to avoid and actually don't push things in the right direction. Sharif, do you have anything in that?
Yeah, for sure. One of the things that I would start with is understanding where is my most risk coming from. As you said, security is a never-ending process, right? There's no way you can tackle all things security. I'm not talking about software security, we're just talking about risk in general. So where would we start? Where is the most risk coming from? Tackle that. By tackling that, understand what is the risk? How do I measure that risk? And a lot of times it's the number of vulnerabilities. Some companies I've seen are putting a weighted score. So for example, a critical is a 20, I don't know, a high is a 10, a moderate is a 5. And this is this is kind of like a custom per organization on how what is their appetite for risk. So the number of vulnerabilities, and the most important is how do I know those vulnerabilities? Are they coming from tools? Are they coming from an external pen tester? Are they coming from static code analysis? So as I mentioned before, my ROI on the tool, I'm paying X amount of dollars for this tool or this consultant or this company, or it might be my engineer's time doing a particular activity, threat modeling, for example. What is my ROI on it? Understanding how many vulnerabilities, how many true vulnerabilities are coming, and then what is the average time to fix those vulnerabilities. And that will give you a quick overview on how are we doing overall for that particular area. Fix that, move to the next, and over and repeat. So understanding the risk, understanding how would I detect this risk, how fast am I to close those gaps, improve that process, and then move into the next area.
Cool, thanks. Misha, have you got anything to add to that?
Yeah, I mean, metrics is one of those things that I think, there's no single metric, right, that's going to give you an answer. And so, yes, as Sharif said, I mean, taking a holistic approach. So the way that I think about it is that, there's the business KPI. So like I said, if you could have security related KPIs, right, that execs are also looking at, that would be great. That might include compliance. Are you meeting, I don't know, PCI, GDPR, HIPAA compliance, that type of stuff, and managing your risk. I think then there's the level of like implementation level metrics as well, like the trainings and how many people are actually, the number of trainings you do per year and how many people are actually taking those trainings and that type of stuff. Perhaps also like the number of issues that like SaaS tools are picking up, and is that a trend that you see? So looking at trends, like is that a trend that's increasing or decreasing over time? but the other thing is this, right? Because like we said, we want security to be an enabler, not necessarily a blocker. And so also looking at efficiency metrics, right? So whatever the Accelerate book has said about those 4 Accelerate metrics, yeah, continue to measure that. That's part of our security story in terms of security development, right? So that includes lead time and mean time to response and failure rates. All of that definitely comes into effect. And then finally, impact. So what are the known vulnerabilities in your system, especially if you're using open source, libraries and stuff like that. How many of them are not at the latest patch, especially if they have high security issues and things like that. The other thing that I really like to use, and we're using, is CVSS score as a way to prioritize the issues. And CVSS is a great tool where you're able to measure each issue that comes in by confidentiality, integrity, and elevation privilege type of statuses, and then that gives you a great score, and then you could be able to look at, so these are all great metrics to be able to see how are we doing in terms of addressing the lower priority issues versus the higher ones, severity issues, and are we prioritizing correctly?
Great, well, thanks very much. We have just run out of time, so we're gonna have to leave it there. I think we've had some great insights there, all about how people can improve their stuff. There's a lot of talking about obviously shifting left, but bringing more people into the process and talking to be product people or other people in the business, and really understanding how you embed that security beyond. I think that's my big takeaway today. It's not just your engineering team's problem. It's company-wide problem, and the more we can all collaborate on these things, I think the better. So we are going to move across to the Slack channel now. We do have we have one question who's come in, which is a really good one around user experience and that sort of stuff. So we can have a chat about that in the Slack channel. That is Process on the lead dev Slack channel. So hopefully to see you there. And thanks everybody for joining, and hope to see you next time. Goodbye.